Hook. A visitor that shouldn't be something streaked into our neighborhood at blistering speed and was shedding metals it shouldn't contain. NASA verified the measurements. Top researchers at Harvard raised urgent questions. No iron, only nickel, and a path through the solar system that looked almost deliberate. Was this a random piece of space debris or something sent on purpose? On the night of July 1, 2025, observers at the Atlas Observatory in Chile noticed a faint, fast dot sliding across the starfield. It was easy to miss at first, just a whisper of light, but when telescopes and spectrometers began to analyze it, the whisper turned into an alarm. The object wasn't following the familiar slow arcs of local comets or asteroids. Its path was hyperbolic, a single pass through our system. Astronomers catalogued it as 3I, Atlas, only the third confirmed interstellar object ever recorded. Its orbital eccentricity, 6.14. For scale, anything above 1 is not gravitationally bound to the Sun. This visitor had come from elsewhere and was not stopping. Its speed was staggering. Measurements showed a velocity around 58 kilometers per second relative to the Sun, about 130,000 miles per hour, faster than any human craft and far beyond the typical speeds of objects born inside our system. By the time we noticed, it had already crossed Jupiter's orbit and was sweeping inward, a lone bullet through the cosmic dark. But speed and orbit were only the start. As the object plunged inward, its chemical fingerprint emerged as something truly baffling. Spectroscopy from the Very Large Telescope in Chile revealed intense emission lines of atomic nickel streaming off the object's coma. Roughly 4.66 grams per second of nickel vaporizing into space as it warmed. Yet there was no detectable iron. Not trace, not faint. Iron, which almost always accompanies nickel in natural space materials, was absent. That's not a small oddity. In meteorites, comets, and interstellar dust, nickel and iron are usually paired, forged together in supernovae and neutron star mergers, frozen into alloys and minerals that survive for eons. Separating nickel from iron on Earth requires industrial refinement. In nature, such a clean split is unknown. Harvard astrophysicist Avi Loeb flagged the anomaly publicly, calling the metal imbalance a chemical outlier of serious consequence. He stopped short of declaring an engineered origin, but his point was stark. This composition did not fit established natural models. More oddities followed. The James Webb Space Telescope turned its infrared gaze toward the visitor and found a comet dominated not by water vapor but by carbon dioxide. The ratio of carbon dioxide to water vapor was roughly 8:1, extraordinary compared to known comets. Webb measured carbon dioxide production near 129 kilograms per second while water vapor output was only about 6.6 kilograms per second. Other gases, like carbon monoxide and carbonyl sulfide, were present in small amounts, but none came close to CO's dominance. Carbon dioxide is fragile on interstellar journeys. It tends to break down under harsh cosmic rays and UV exposure. Yet here it was, abundant and persistent. Explanations proposed by some researchers ranged from a protective crust that only recently exposed volatile layers, to formation in an environment unlike anything familiar. There's also the provocative, quiet suggestion from a few quarters. Could the carbon dioxide spike be deliberate, a conspicuous chemical signature placed to be noticed? The parallels to Oumuamua are immediate and unnerving. The first known interstellar visitor in 2017 confounded observers. It showed no obvious gas or dust, yet it exhibited unexplained acceleration and an unusual shape inferred from its light curve. That object led to wild debate, from novel ice sublimation to exotic hypotheses like a light sail, and pushed many scientists to confront possibilities they had dismissed for decades. Now, with 3I, Atlas exhibiting its own set of anomalies, the question becomes harder to ignore. Are these isolated flukes or clues to something larger? Looking deeper, investigators examined 3I, Atlas's path. When orbital models are run backward, the trajectory threads unusually close to Venus, Mars, and Jupiter, three planetary encounters that, statistically, have a vanishingly small chance of occurring by accident. Simulations suggest the probability of such alignments by pure chance sits near 0.005%, roughly 1 in 20,000. The object's motion is retrograde, opposite the planet's motion, and lies nearly within the ecliptic plane, tilted only about 5 degrees. In short, it skimmed through the planetary plane in a way that reads less like a random bombardment and more like a sweep designed to intersect key orbits. Natural scenarios have been proposed. One idea points to the violent birthplaces of heavy elements. Neutron star mergers and asymmetric supernovae can eject clumps of exotic composition. In kilonovae, the rapid neutron capture process forges heavy elements and could, in principle, produce nickel-rich fragments with unusually low iron content. Asymmetric supernova jets can shoot element-specific plumes into space, potentially leaving behind metal fragments dominated by nickel. But even these scenarios usually leave some iron, and the total absence of iron in 3I, Atlas remains hard to reconcile. Then there's the isotopic angle. Isotopes, atoms of the same element with different neutron counts, act like cosmic fingerprints. Teams worldwide are now pursuing isotopic analyses of both the nickel and the carbon compounds carried by the object. Early hints suggest isotope ratios that don't fit neatly into known categories of meteorites or supernova ejecta. If confirmed, those patterns could be a smoking gun, a distribution of isotopes unlikely to arise from natural nucleosynthesis, possibly indicating deliberate selection or manufacture. All of this opens a mind-bending possibility. What if this isn't a message transmitted by radio or light, but a message encoded in matter itself? Humanity already encodes information chemically. DNA is nature's archival medium, and isotopic markers on Earth are used to trace events, origin, and age. It's conceivable that an intelligence trying to leave an immutable, long-lasting sign could encode information in elemental and isotopic patterns, designing objects to look like natural visitors while carrying a signature that stands out to those who know where to look. We must be careful. None of the current measurements prove an artificial origin. But the convergence of oddities, extreme hyperbolic speed, unusual orbital geometry, nickel without iron, a carbon dioxide-dominated coma, and atypical isotope hints, makes the case worth watching. Two strange interstellar visitors in a decade is not what the record books predicted. Either the galaxy is richer in weird natural fragments than we realized, or we are beginning to detect something intentional. Finally, a note on human history. We've long revered metals from the sky. Ancient Smiths prized meteoritic iron and used it for sacred blades and jewelry. Those artifacts, sometimes rich in nickel, carried meanings beyond mere utility. If an advanced agent wanted to communicate across time and space, perhaps they would choose materials too durable, unmistakable, and meaningful to metallurgists everywhere. So we return to the core question: coincidence or signal? Only more data will tell. Laboratories around the world are racing to extract more from the fading trail of 3I, Atlas, before it becomes another silent wanderer. Is it a rare product of cosmic violence, or an engineered messenger sent on a deliberate path? Either answer would rewrite part of our understanding of the universe. The clock is ticking, the evidence is mounting, and the cosmos has once again handed us a riddle written in atoms.